In this lesson, we will work on rational exponents. So before we talk about rational exponents, we should really review about positive and negative exponents. So let's do 2 cubed, for example. Okay, a positive exponent means you're repeatedly multiplying. So like 2 cubed is 2 times 2 times 2. Whereas a negative exponent means you are repeatedly dividing. So you're dividing by 2, dividing by 2, dividing by 2. All right, so we know what a positive exponent means, we know what a negative exponent means, but what about a rational exponent? So this is basically our last level of exponents in terms of what we're doing with high school math. So you have negative exponents, positive exponents, zero exponents, and finally rational exponents. So we actually defined x raised to the power of half earlier. When we talked about simplifying radicals, we defined, I don't want to spoil it just in case you forgot, but we defined that. Okay, x to the power of 1/2 is equal to, whatever we learned earlier. So just in case you forgot, I will show you how we got to the relationship. So if 2 squared is equal to 4, if 2 squared is equal to 4, then root 4 is equal to 2. Okay? If 3 squared is equal to 9, then root 9 must be equal to 3. So let's take a look what we wrote here. If x to the power of 1/2 squared is equal to x, and that is true because when a power apply the power law of exponents, multiply half times 2 is 1, which is just x, it's just x. So if x to the power of 1/2 squared is equal to x, based on the power law of exponents, then we can say root x is equal to x to the power of 1/2, right? It's exactly the same as what we did. For example, 3 squared is 9, then root 9 is 3. If x to the power of 1/2 squared is equal to x, then root of x is equal to x to the power of 1/2, okay? So these two are equivalent, okay? Which we said earlier when we learned how to simplify radicals. So root x is equal to x to the power of 1/2. But root x is said to be in radical form. Okay, because you see the radical. Now, x to the power of 1/2, that's considered to be an exponential form. Okay, they're equivalent. It's just in different forms. So radical form, exponential form, and you must be wondering which one is better. Well, I would argue it depends on the situation. So later on we'll see when we prefer the radical form and when we prefer the exponential form. Okay, so let's answer this question. X to the power of 1/2 is defined as root x. And you can actually keep going. If I have x to the power of 1/3 cubed, it's equal to x. So, let's do one more. If 2 cubed is equal to 8, then cube root of 8 is equal to 2. So if x to the power of 1/3 cubed is equal to x, once again that is true based on the power law of exponents, then the cube root of x is equal to x to the power of 1/3, right? So this is the cube root. The 3 is called the index, okay? And if you want to generalize a little further, if your exponent is 1 over n, that means you're taking x to the nth root, okay? You're taking x to the nth root. So it could, if your exponent is 1/4, you're taking to the 4th root. You can take it to the 5th root, 6th root, so forth and so on. Okay, so that is going to be very helpful. That's going to help us work with rational exponents. Now, when you work with rational exponents, the numerator of the rational exponent may not be 1, right? It could be, but it's not necessarily equal to 1. So we have a over b is your exponent, your rational exponent, and let's say they're integers. Okay, so a over b, you can express a over b as a times 1 over b, or you can express it as 1 over b times a. So if you express it as a times 1 over b, you can use the power law of exponents and write it as x to the power of a raised to the power of 1 over b, because it's a product, right? A times 1 over b, so you can express it as a power of power. So x to the power of a raised to the power of 1 over b, what you're going to do is take x to the raise it to the power of a, and then take it to the bth root. Now, if you have it the other way around, if you have it as 1 over b times a, which is once again the same as a over b, what you're really saying now is you're going to take x to the bth root first and then raise it to the power of a. So it doesn't matter. You could take it to the bth root first and then raise it to the power of a, or take it to the power of a first and then the bth root. Okay, and that's because a times 1 over b is the same as 1 over b times a. So really, when you see a rational exponent now, what you should really see is that the denominator of the rational exponent tells you the root, and the numerator of the exponent tells you the power. Okay, root and power. You know, I'm going to prove example 1 in a second. I just want to, since this is fresh in our minds, I'm going to do example 2 first, actually. Okay, so the exponent here is 2/3. So what does that mean? I'm going to take it to the cube root and square. Which one do I do first? Well, it doesn't matter. I can do either or. Okay, I'll show you both ways. I'm going to cube root the 8 and then square. Well, cube root of 8 is 2, and 2 squared is 4. Beautiful. Or I can square first and then cube root. No problem. So square first and then cube root. Beautiful. You get 4 either way. And if you're allowed a calculator to check your answer, so different calculators look you have different buttons, but oops. 8 to the power of 2/3. 4. Perfect. Okay. All right. -8's your base, and your exponent is 1/3, which means this one, you don't have to raise it to the power, well, I guess you raise the power of 1, which changes nothing. So all you're doing to -8 is you're just cube rooting. Okay, so cube root of -8 is -2. Because -2 times -2 times -2 is 8. All right. Here you have a negative exponent here. So I'm gonna I hate skipping back and forth, but I'm gonna skip this because there's a exponent law to help us later on. So I'm gonna do D. I promise you will do C. Okay, so here, the exponent's 4/5, which means I'm gonna take it to the 5th root and raise it to the power of 4. Or you can raise it to the power of 4 first and then take the 5th root. Now saying that, I'm not very good. I have no idea what 243 raised to the power of 4 is. Okay, so because that is the case and I don't want to use my calculator, I'm going to take it to the 5th root first. I personally prefer to take the root first because I'm great at shrinking the number and then raising it to the power. I don't want to make it a giant number first and then take it to the root because I don't work with those giant numbers often enough. All right, so the 5th root of 243 and then raise to the power of 4. I'm going to take the 5th root of 32 and raise it to the power of 4. Okay, so I know the 5th root of 243 is 3. If you don't know that, then you have to use your calculator. I'll show you how to use the 5th. So most calculators, you push the index, you type in the index, and then this button, 243. So yep, that's 3. And 3 to the power 4 is 81. The fifth root of 32, you can check with your calculator, but it's 2, and 2 to the power 4 is 16. Okay, ooh, a negative exponent, negative and rational. Beautiful. Okay, so negative 1 over 4 to the power of 1/2. But remember, an exponent of 1/2 is just square root, right? So it's just negative 1/2. Okay, so C, you have a negative exponent. Now, you may have learned this from grade 10 as well. If you have a negative exponent, you can just take the reciprocal of the base. Now, just in case you forgot, I'm going to prove it. So I'll work with the left side. Okay, let's play around with the left side. Okay, so I'm trying to prove that if you have a negative exponent, you can change the exponent from negative to positive by taking the reciprocal of the base. So, you know what? Let's take the numerator, raise the power of negative n, denominator raise the power of negative n. Okay, now, you learn that if you have a negative exponent, you take the reciprocal because it's repeated division, right? So if it's in the numerator, it goes to the denominator. If it's a denominator, it goes to the numerator. Okay, the term will basically go from numerator to denominator or denominator to numerator. So that means now you have b to the n in the numerator and a to the power of n in the denominator. So b to the n over a to the n, which means it's all of b over a raised to the power of n, which is the same as the right side. Okay, QED, which means I've proven what they asked me to prove. We'll talk more about QED later on, but it basically means that you've done what they asked you to prove. All right. So if the exponent here is negative, I can take the reciprocal of the base. So instead of 49 over 81, it's now 81 over 49. Exponent is positive, so I have to square root and cube because the exponent is 3 over 2. Square root and cube. So square root 81 and then cube it. If you really want, you could cube it and then square root. But I don't know what 81 cubed is. Actually, do I know 81 cubed? 3 to the 4. I have an idea. Now I have to check. Square root of 49 cubed. So you have 9. Square root of 81 is 9. 9 cubed is 729. Square root of 49 is 7. 7 cubed, 343. No. By the way, if you were to cube 81, that's 531,441. So, yeah, it's a good idea to square root first. Okay, so now these questions, I know they look challenging, but they're really the same thing as what you did last year, except now you have rational exponents. So none of these are written in radical form. None of these are written in radical form, and I would argue radical form would not be a very good idea. If it was expressed in radical form, I would change it to exponential form. You'll see some of that in the homework. So if it's in radical form, change it to exponential form, because I want to see the exponents. I really want to see the exponents if I'm going to apply the exponent laws. If I want to add the exponents, I want to see the exponents. Okay, so if you want to simplify these exponential expressions, it's a good idea to have it in exponential form. Okay, so this negative exponent, you could deal with it now or later, so let's do it later. So negative 2 times a quarter is negative half. 16 to the power of 4, 1 over 4, we'll do that after. Half times a quarter, power, so 1 over 8. Okay, negative exponent means that term is now in the denominator. The fourth root of 16 is 2. So v to the power of 1 over 8 and w raised to the power of half. And you can absolutely leave it in exponential form. There's no need to change it to radical form. All right, so now for this question, I'm going to simplify because within the brackets, I can definitely clean that up a little because I have x squared over x to the power of negative half, for example, which means 2 minus negative half is 2 plus half, which is 2.5, so it's 5 over 2. Negative 2/3 minus negative 1/3, which is negative 1/3. So negative 2/3 plus 1/3 is negative 1/3. And that makes sense because when I divide powers of the same base, I subtract exponents. And now I raise everything to the power of negative 1 over 7, which means I'm going to multiply the exponents by negative 1 over 7. So that gives me negative 5 over 14. And that's 1 over 21. But be careful, I'm not allowed any negative exponents for my final answer, just like in grade 10. There we go. Awesome. All right, so here, once again, I'm going to simplify in the brackets first, inside the brackets. So it's 3 over 2 minus 2 because of the quotient law of exponents. So 1.5 minus 2 is negative half. Nothing happens to b. Negative exponent. And there we go. So that's how you work with rational exponents. The numerator tells you the power and the denominator tells you the root.